Hi everyone, welcome to my channel Pure Biology, and today I come with another video, that is the scattered plot. Okay, so this is also topic related to the cell signaling. So here, or you can say cell biology. So here this topic is very not so tough. This is very easy, but you have to first completely understand about what is the plot and how will it be demonstrated, okay, or it derivated. So before going to this topic, I want to say thank you to all of you who have already subscribed my channel, and it's my humble request to the newcomers, please do share and subscribe this channel if this is helpful to you, okay. And if you will give more support for my channel, then I always try to give you the best, okay. So this is the scattered plot. What is this? This is the graphical method of analyzing equilibrium ligand binding data, okay. This is the graphical method of analyzing equilibrium ligand binding data, and this is used to determine the number of ligand that binding sites, okay. That means number of binding sites present in the ligand, you can say, okay. Or another way you can say that number of ligand binding sites on the receptor. This is, I think, appropriate definition. That is the we can determine the number of ligand binding sites on the receptor, okay. Whether these sites show cooperative interactions, whether more than one class of exist, and the respective affinities of each site. So this is also done for determining the number of ligand binding sites that present on the receptor, and obviously which has the more affinities. This is also can be determined by this process, okay. And here, suppose one receptor R and ligand L that form RL, or receptor ligand complex. So here this is the one constant we have to take, that is the Ka, and the Ka is that RL by concentration of RL by concentration of R into concentration of L. And if we write in reverse way or inverse way, then the constant may be changed, and that is become the Kd. And in that situation, the concentration of R by concentration of L divided by concentration of Rl. So the fractional saturation of the site is what? That is, we have to take this is as Y. So Y is the concentration of L bound to R. Concentration L bound to R by the total concentration of R. So here we have to write in that way, that the concentration of RL divided by concentration of R plus concentration of RL. Clear? Concentration of RL means L bound to R, and the concentration, total concentration R, that is included as R or also included within the RL. Okay? So the value of Y, this is the Y, the value of Y that ranges from 0 to 1. When 0? When RL is 0, that means the RL, if the RL is 0, then the value of Y becomes 0, because you put here 0, you put here 0, that means the value of Y becomes 0. And when it becomes 1, when the R is 0. So R is 0 means RL that is cancelled, and the value becomes 1. Clear? Now to determine the value of Kd, we rearrange the equation 1, or we have to rearrange the equation 1. That is, okay, this is the equation 1 and this is the equation 2. So equation 1, just we have to write RL in the left side, and we have to write this Kd in just below the concentration of R and concentration of A. So I have written in that way. Clear? Now substituting the expression for RL in equation 2. This is the equation 2. Here we will get we got that the value of RL, that is R, concentration of L by Kd. So we have to put this value where just in presence of RL. Clear? So instead of RL. So just instead of RL, we have to write this value. Clear? So concentration L by Kd, and obviously R is similar, but this value is not written here. We have to write this value. So concentration of R, concentration of L by Kd. And you know that here I just write this number just below this one, okay, in the next step. And so what is happening? R, and in the next step I just separate two of this, okay. This is the method, two of this with this, okay. So in first step R by this one, and in the second step the R L Kd by R L Kd, okay. So the value is 1 by L by Kd plus 1. So now you just LCM this value, just you can LCM this value and getting this Kd plus L, that is the L. And in the next step I just have written this A in the upside and or upper side, and Kd and L in the below. So the value of Y is that concentration of L by Kd plus concentration of L. Clear? And you can write in the reciprocal way that 1 by Y plus 1 by Y equals to 1 plus Kd by concentration of L. Okay? And here another step, just I have written that from this side we can just cross multiply this. So we will get this one, and just interchanging the sides we will get this, okay, just this one, and after just A we have to take common, and the value is that. So in the next step I just rearrange the equation and form that 1 by Kd minus 1 by Kd equals to Y by concentration of A. Okay, so this is the actual value or actual equation by which we can draw a graphical slope. So we will see in the next part or in the after wrapping this one. So what will we get? That a plot of Y by L, concentration of L versus Y, that gives a straight line of slope, that is minus 1 by Kd. Okay, so this is the straight line. Now we have to understand how to draw this straight line. Okay, so first we wrap this one and I will try to see this next part. Okay, so here if the receptor has n equivalent binding sites for ligand, in that situation we have to consider the case in which the macromolecule has n equivalent sites, okay, and here each binding site has the same Kd value, okay. So in that situation Y equals to n concentration of L divided by concentration of L plus K. In that way we have to take an equation, and the value of K, that may be K1, K2, K3 for n sites, okay. And now you just simplify this equation in such way, just cross multiply this one, so we will get this, and after that both the sides are divided by the K, so we will get this value. And now just transferring or rearranging this equation, we will get the value of Y, that is equals to N concentration of L by K minus Y concentration of L by K, okay. So, and in that way again we rearrange this situation. Just mean we have to take a common L, so we will get this value. And now L is written in the just below the Y, so we will get this value. Now this is the equation by which we can draw this line, straight line, okay. And the first one is the equation of that one, that is, first I explained you that which one, Y by L equals to 1 by KD minus Y by KD, okay. So this straight line is drawn here by following the first equation, where Y by L, that is equals to 1 by KD minus Y by KD, okay. So here the Y is written here and Y by L is written here, and the slope is this one, and its value is minus 1 by KD. But when n number of sides are there, you can see the straight line just touch this 6 value and touch this 3 value. Here you can see that no touch is the end points, okay. The two end points of the straight lines not get to be touched, okay. But here the end points are touched to the y-axis and the x-axis, okay. And here x-axis is that following the y value, and the y-axis that following Y by L value, okay. So this is the main difference between the n number of sides, presence of n number of sides or without n number of sides. Another important thing is that the plot that is concave downward, it is situated or it is occurring for the non-linear plot, okay. These are to the non-linear plot. So here this factors or this situation not be included. But when the plot is or the line is not linear, in that situation concave, if the line is concave downward, that indicates the positive cooperativity between the binding sites on an allosteric receptor. And in second type, that is also arises when the multiple classes of binding sites with distinct affinities are present on the receptor. These are very complex. So here we will not learn about this non-linear scattered plot. Here we will learn about the linear scattered plot, okay. So scattered plot is that how by this plotting we can easily identify the number of sites that presents on the receptors, or what sites, the ligand sites that present on the receptors, and obviously the affinities of that ligands and the site of the receptor also can be determined by this plotting, okay. So you will obviously learn, you will try to learn about the nonlinear plot from any cell biology book, but here I just explained about the linear plot, okay. So cell signaling process, I think I have only one topic I have to explain to you. So all the cell signaling process consisting of different topics that already explained, okay, that are totally explained in my videos, and I have uploaded all this topic related cell signaling process. So only one topic that is related to this signaling process I have to explain with you. So I will try to give this explanation in my next video, okay. So thank you, and I have to say one word, that if you subscribe this channel, obviously press the bell icon for getting the notifications, because I generally upload my videos either Tuesday and Thursday or Saturday and Sunday, okay. So you will get all the notifications if you just press the bell icon after subscribing my channel, okay. Thank you.